Welcome to The Explainer. Today, we're going to pull back the curtain on something we all use every single second, but probably never think about: the Internet's network layer. It's the magic system that lets you send a message from your laptop to a server on the other side of the planet, all in the blink of an eye.
All right, so let's kick things off with a question that sounds simple, but the answer is mind-bogglingly complex.
I mean, really think about it for a second. Your little message has to navigate this tangled global maze made up of millions of different networks. They're owned by different companies, they use wildly different technologies. We're talking fiber optics, Wi-Fi, cellular data. How on earth does it all work together? It honestly seems impossible.
And the answer, the solution to this seemingly impossible puzzle, is something called the network layer. The easiest way to wrap your head around it? Just think of it as a global postal service, but for digital information. Its one and only job is to get a little packet of data, called a datagram, from where it started to where it's going, no matter what crazy path it has to take.
Okay, so if we're running with this postal service idea, what's the very first thing you need? Addresses, right? You can't just drop a letter in a mailbox with no address and hope for the best, and the internet is exactly the same way.
Yep. Every single device that connects to the internet, your phone, your laptop, that smart TV, even your friend's fancy connected toaster, gets a totally unique identifier. We call it an IP address. And that right there, that's the universal mailing address for anything, anywhere online.
Okay, so this is where it gets really cool. How does our data actually get packed up for this trip? Well, it gets sealed inside a digital envelope, which we call an IP datagram. And just like a real envelope, the most important stuff is right on the front. In what's called the header, you got the from address, the source IP, and the to address, the destination. It even has this clever little thing called a time to live, which is basically an expiration date to stop a lost packet from just bouncing around the internet forever. Pretty smart, right?
So a question probably just popped into your head, right? How do you even get one of these IP addresses? I mean, you don't type one in every time you connect to a new Wi-Fi network. And you're absolutely right. It all happens automatically, behind the scenes, in a split second.
It happens through this super quick 4-step chat called the Dynamic Host Configuration Protocol, or DHCP. It's basically a little negotiation. Your computer just shouts out to the network, "Hey, anyone got an IP address for me?" A server on the network replies, "Yep, I'm here. You can use this one." Your computer says, "Awesome, I'll take it." And the server finishes with, "Great, it's all yours for a little while." And bam, just like that, you're on the network.
Okay, so let's recap. Our little packet of data has its address. It's sealed up in its digital envelope. It's ready to go. Now for the big question. How does it find its way through that tangled global maze of networks?
Well, this is where the real workhorses of the internet come into play: routers. You got to think of these things as the internet's post offices or sorting facilities. Their one and only job is to grab an incoming packet, take a super fast peek at the destination address, and then zip it along on the best path to get it one step closer to where it needs to go.
And routers have basically two main philosophies for figuring out that best path. On one hand, you've got link state routing. Think of this as giving every single post office a complete, detailed map of the entire country. They can see everything and calculate the absolute best route themselves. Then you have distance vector routing, which is more like asking for directions. Each post office only knows about the towns right next to it, and it just asks its neighbor, "Hey, which way to Chicago?" It relies on the next guy in the chain to know the way.
Okay, but let's zoom out even further. The internet isn't one single thing, right? It's a massive network of networks. These huge independent networks, think of the ones run by big internet service providers, are called autonomous systems. And to get them all to cooperate and talk to each other, they use one main language, a protocol called BGP. This is like the grand international treaty that connects all the different countries' postal services into one global system.
All right, we've got all the pieces now, don't we? We've got the address, we've got the envelope, and we've got the post offices. So let's put it all together and follow one single packet on its incredible journey from start to finish.
Okay, so you type in a website and hit enter. First, that request gets encapsulated, stuffed into that IP datagram envelope. Then it makes its first hop to your local router at home. That router looks at the destination IP, checks its little map, its forwarding table, and boom, sends the packet to the next router in the chain. And this process just repeats itself over and over. Hop, 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 across maybe dozens of routers and even across different huge networks, until finally it arrives at the last router, which delivers it right to the server's doorstep. And the craziest part, this whole trip takes just milliseconds.
So we just traced the life of one tiny packet. But now let's zoom all the way out, because understanding that journey lets us appreciate just how unbelievably ingenious this whole system really is. It is the absolute linchpin of the entire internet.
You have to remember, the original goal, and you can see it right here in this quote from the pioneers of the internet, Vint Cerf and Bob Kahn, wasn't just to connect a bunch of similar computers. The real challenge was to link totally dissimilar networks. They knew they'd have to deal with all kinds of different technologies, different speeds, different rules. They needed some kind of universal translator.
And that is the absolute genius of the network layer. It creates that universal common ground. It doesn't care if one network is built on super-fast fiber optics and the next one is a shaky cellular signal. By using this system of IP addresses and datagrams, it creates a universal language that lets any technology talk to any other technology. It's the ultimate peacemaker. I mean, to put it as simply as possible, the network layer is literally the inter in internet. It's the critical ingredient, the very glue that holds this whole global thing together and makes it feel like one single seamless network.
And that brings us to a final, really big thought to leave you with. We've just broken down this amazing system that powers our world today. But what happens next? What happens as we plug in the Internet of Things? When it's not just our computers and phones, but billions, literally billions of new devices, from our cars to our toasters to tiny medical sensors. They're all going to need their own unique spot on this global network. The incredible scale and the sheer genius of the network layer, well, it's about to be tested in a way it has never been before.